It's midnight. You wake up and go to the bathroom, and in the dark corner, you see it. A tiny body suspended by legs absurdly long and thin. And then the fear kicks in, and your immediate thought is to get rid of it. But what you don't realize is that this specific spider, that sometimes people call Daddy Longlegs, is on a secret mission to actually help you. Now, before we go any further, the spider that I'll talk about in this video goes by a few names. Most people call it Daddy Longlegs. But what's interesting is that many people use that nickname, Daddy Longlegs, for other creatures as well, like harvestmen, crane flies, and just about anything else with long legs and a small body. But today we're talking specifically about the cellar spider. You can identify it by its pale body and its legs that stretch far out in every direction, and the loose, chaotic web it builds in corners and ceiling gaps. So, now that you know what it looks like, what do you actually do when you spot one? First, leave the web. This is harder than it sounds because the web looks awful. Cellar spiders build what arachnologists describe as an irregular three-dimensional tangle web. It's loose, asymmetrical, with no geometric structure. Compared to the orb weaver's precise spiral or the funnel spider's ordered sheet, a cellar spider's web looks like an accident, like something that happened rather than something built. Most people's instinct is to destroy it. But you see, that web is a working trap. It is catching whatever passes through that corner: mosquitoes, gnats, moths, flies, and critically, other spiders that wander into the same space. The mess is functional. The structure catches prey precisely because it's three-dimensional and unpredictable. An insect flying into it hits multiple strands at multiple angles simultaneously and cannot free itself the way it might escape a single flat sheet. Leave the web, and you leave an active pest trap in place at no cost. Second, stop identifying it as dangerous based on its appearance. The cellar spider's long legs and small body trigger the same immediate alarm response as more threatening spiders. Something about the proportion of leg to body reads as wrong to the human visual system, in the same way the house centipede does. But this fear is unwarranted. University of California Riverside entomologist Rick Vetter, who has spent years studying and debunking arachnid myths, is direct on this point. There is no documented case of a cellar spider bite causing any significant medical reaction in a human. The spider's venom is mild relative to most other spider species. Mythbusters tested the venom bite directly on a human subject and found a brief, minor burning sensation. That is the extent of the medical risk. Third, if it vibrates, don't be scared. When a cellar spider is alarmed by a vibration in its web, maybe because of a large nearby movement, it detects that as a potential predator and it begins to spin rapidly. The spider sets itself into a fast rotation within its web that turns its body into a blur. From a human vantage point, this looks erratic and alarming. Several spider researchers have noted that the vibration behavior reads to most people as aggression or panic. However, the biological explanation is far simpler. The spider cannot outrun a threat and cannot fight one. Becoming a visual blur is a passive defense. You see, an animal that your eyes can't lock onto is harder to target. Within a few seconds, it stops, reassesses, and either resumes normal position or waits. The performance is for predators. You are not a predator for the spider, so just observe quietly or go away from it. Fourth, resist using broad-spectrum pesticides on it. This applies specifically to people who spray dark spaces like garages, basements, utility closets as a general pest prevention measure. Cellar spiders are far more sensitive to residual pesticide than most of the insects the spray is intended for. They contact surfaces constantly as they move through their webs and across walls. A space treated with residual spray will lose its cellar spider population within days. The insects that the cellar spider was protecting you from will not run rampant in your home. The pest suppression the spider was providing disappears. Now, The fifth is the most important thing anyone can do about the cellar spider in their homes. But to understand this tip, you first need to know what this spider actually is, because most people who've encountered a cellar spider have only heard the myths, and they're wrong about almost all of it. The name daddy longlegs is one of the most overused terms in North American wildlife. 3 completely different animals share this nickname, and the confusion this causes has real consequences. People make pest control decisions based on the behavior and reputation of one animal when they are looking at a completely different one. The harvestman, which most entomologists consider the most correctly named daddy longlegs, is an arachnid, same broad category as spiders, but not a spider in any meaningful biological sense. Harvestmen belong to the order Opiliones, while spiders belong to Araneae. They share 8 legs and an exoskeleton and almost nothing else. Harvestmen have 1 fused body segment. Spiders have 2 distinct segments with a narrow waist between them. Harvestmen have 2 simple eyes. Spiders have 8. Harvestmen cannot produce silk. They cannot spin a web of any kind, but most importantly, harvestmen have no venom glands, no fangs or any ability to inject anything. The version of daddy longlegs that produces the playground legend about deadly venom is the version that has no venom at all. Now, why call it daddy longlegs? Well, nobody knows exactly where the common name came from. The longlegs part is straightforward. The daddy remains unexplained. Arachnologists and entomologists who have researched the etymology of the name have not found a satisfying origin. The name appears in written English at least as far back as the 17th century, applied to the harvestmen, and spread to other long-legged animals over time through the kind of folk naming that cares more about appearance than taxonomy. Today, depending on where you grew up and who taught you the name, it might mean the harvestman you find on a log in the woods, the cellar spider in your ceiling, or a crane fly hovering near a porch light at dusk. The second animal sharing the name is the crane fly, a long-legged insect that looks like an enormous mosquito. Crane flies are also harmless, also frequently confused with the cellar spider, and entirely irrelevant to the venom myth since many adult crane fly species have no functioning mouthparts. They hatch, they mate, they lay eggs, and they die, often within days of reaching adult form, having eaten nothing. The third animal is the cellar spider itself, family Phalcidae. That's what we're focusing on in this video. This is the one in your ceiling corner and the only one of the 3 animals I mentioned earlier that is a true spider. It has 2 body segments, 8 eyes, silk-producing spinnerets, and functional venom glands with functioning fangs. When the popular show Mythbusters tested whether a cellar spider could bite a human, the answer was yes, it could. The spider's fangs are not too small to pierce human skin. The myth about the venom is another story though. The venom from the bite resulted in a brief, minor burning sensation, but nothing further. The comparison they ran against black widow venom showed the black widow's venom to be dramatically more potent. Myth busted. The origin of the myth is likely rooted in something people actually observed. Cellar spiders kill and eat other spiders, including spiders significantly larger than themselves. Bristow's 1958 landmark work on spider biology documented cellar spiders taking a significant toll on other spider species entering buildings. Jackson and Brassington's 1987 study in the Journal of Zoology described the cellar spider's predatory behavior toward other spiders in specific detail, including a behavior called aggressive mimicry. The cellar spider sometimes enters the web of another spider and produces vibrations that mimic the signals of trapped prey. When the resident spider investigates, the cellar spider attacks. The predatory versatility is well documented. An animal observed killing spiders that are known to be dangerous naturally generates a folk belief that the predator must carry something extraordinary necessary to achieve it. The cultural footprint of the daddy longlegs across all three animals sharing that name runs wider than most people would expect. In parts of rural America, folk belief held that killing a daddy longlegs would bring bad weather. In England, children recited rhymes to the harvestman asking it to show them where cattle had gone. The Irish considered it unlucky to harm one. The Australian species of cellar spider was sometimes called the skull spider due to the pattern visible on some individuals' abdomens. In Japan, the harvestman appears in a specific category of folk illustration associated with autumn. These cultures were each looking at a different animal while applying overlapping emotional valence. Something slightly uncanny, something that occupied the margins of the house, something that defied easy classification as either friend or enemy. The cellar spider's position in human domestic spaces goes back centuries. It evolved to live in structures in places like the stable, the cellar, the outhouse, the stone walls. It followed humans and their buildings across the globe. The biology behind how a cellar spider actually overcomes prey much larger than itself is more interesting than venom potency. What the cellar spider does when a larger spider enters its web or its territory is cast silk. It casts a lot of it and fast. Before the other spider can orient and respond, the cellar spider moves around it, wrapping it in swaths of silk that bind the legs, the body, and the fangs. The prey is immobilized before it ever has the chance to defend itself. This technique was specifically described in research at Missouri Department of Conservation. The cellar spider casts long swaths of silk onto prey, binding it at a distance, and only approaches for the killing bite once the prey is fully wrapped and helpless. Now, venom potency is almost irrelevant to this strategy. The spider with the longer silk delivery range wins regardless of what either venom would do in direct contact. This is how cellar spiders kill black widows. A black widow entering a cellar spider's territory in a dark garage corner is not facing a spider with venom more potent than its own. It is facing a spider with a reach advantage, a three-dimensional web it cannot navigate well, and a wrapping technique it has no defense against. University entomology programs list cellar spiders as natural predators and control agents of black widows and brown recluses in indoor environments. The species most commonly found indoors across North America is Fulcus phalangioides. Its name translates roughly as cross-eyed legs, a reference to its 8 eyes arranged in 2 groups, each group angled slightly inward. Those eyes are functional, but not high resolution. The spider detects prey primarily through vibration sensitivity in its legs, which register the frequencies created by an insect or spider contacting the web. The response is fast. When prey is detected, the cellar spider moves toward it rapidly, begins casting silk immediately, and completes the wrapping process in seconds. Fulcus phalangioides is one of the most cosmopolitan spider species in the world. It is across every inhabited continent, found in buildings wherever temperatures remain moderate year-round. It likely originated in subtropical Asia and spread globally through human commerce and construction over centuries. In North America, it's active 12 months a year in climate-controlled indoor spaces. Your garage in January likely has the same cellar spider population as your garage in July, working through whatever is in range of the web in the ceiling corner. Pest Me Off service call records from Collin County, Texas, covering 2023 to 2026, found cellar spider populations at roughly equal frequency every month of the year in indoor environments with stable temperatures. There is no seasonal reprieve from their presence, which means there is no seasonal reprieve from their pest suppression. Population density in productive indoor environments can reach levels that surprise people. The British naturalist Steve Hopkin documented what he believed to be the highest density of Fulcus phalangioides in Britain in one building, a concentration significant enough to prompt published notes in the arachnological literature. High density in a single space is not unusual. Where prey is abundant and conditions are stable, the population builds. A house with an active basement insect population will accumulate more cellar spiders than one without. The spider is tracking its food supply. Rausch and Radebaugh's 1993 study specifically examined the relationship between web size, web density, and prey abundance in Fulcus colonies. They found web density correlates directly with prey abundance in the local environment. More insects in the space means more webs, bigger webs, and more spiders. A ceiling corner with an unusually large or active cellar spider population is a corner with a meaningful insect presence nearby. The spider is telling you something about the pest load in that space, the same way the house centipede tells you about pest load in a wall cavity. The female carries her egg sac differently from most spiders. She holds it in her chelicerae, her mouth parts, rather than attaching it to a surface or silk anchor. She carries it with her as she moves through the web, rarely setting it down, repositioning it as she navigates. If you see a cellar spider with a translucent cluster held in front of its face, that is an egg sac. The eggs inside are visible through the thin silk wrapping. She will carry that clutch until the spiderlings hatch and disperse. The spiderlings that emerge from the sac often remain with the mother for a short period before dispersing to build their own webs. In a space with stable conditions and good prey availability, multiple generations can be present simultaneously in the same area. One more piece of biology worth knowing because it explains something you may have noticed without having a name for it. Cellar spiders absorb old webbing. When a web in a corner becomes old and full of trapped debris, the spider has been documented consuming the silk rather than abandoning it entirely. Silk is protein. Recycling it is efficient. The messy, graying tangle in a corner that seems to have been there forever may have been there in some continuous form for a very long time, rebuilt, extended, consumed in sections, and rebuilt again by the same individual or its descendants. The web is managed, not abandoned. That distinction matters because a web that looks abandoned is often still active, and sweeping it out removes something that took weeks to establish and days to replace. The silk recycling behavior also helps explain something specific to pest control. A cellar spider web accumulates chemical signals over time. The debris caught in it, things like the cast skins of insects, the husks of prey, the chemical compounds left by passing arthropods, all creates an information-rich environment that the spider can read through its vibration-sensitive legs and its chemoreceptors. An older, denser web in a productive corner is not a sign of a spider that has given up maintaining its trap. It is a sign of a spider that has been catching enough prey to maintain its position and has built up a detailed sensory record of what passes through that corner. Cleaning it out resets that record. Cellar spiders are generalist predators, but their tendency to occupy the same corners, crevices, and dark spaces that black widows prefer for shelter and web building creates a natural dynamic. Black widows are ambush predators that wait in dark, undisturbed spaces. Cellar spiders live in those same spaces year-round. When a black widow enters a cellar spider's territory, it faces the same wrapping strategy the cellar spider uses against any prey, casts silk at range before the black widow can deploy its own venom. Extension entomology programs across the South and Southwest, where black widow populations are most significant, describe this predatory relationship directly and cite it as a reason to tolerate cellar spider populations in garages, basements, and utility spaces. UC Berkeley's Urban Pest Management Resources note that in structures where cellar spider populations are well established, other spider species, and including more hazardous ones, are less commonly observed. The presence of cellar spiders in a dark space in your home is the closest thing to a reliable biological indicator that black widows are absent from that same space, a documented tendency, not a certainty, but a tendency with enough field observation behind it that it changes the calculus of what cleaning out the corner actually costs you. I already talked about 4 things you can do when encountering daddy longlegs, and with all the context earlier, here's the 5th and final tip. The spider hanging in the ceiling corner of your garage is an indicator, a working trap, a passive monitoring system for the thing you would actually have reason to worry about. Its presence in a corner tells you something about that corner that no other method delivers for free. So leave the web, leave the spider, vacuum the floor beneath it if you want a cleaner space. But the corner above the water heater and the gap between the garage ceiling and the wall can stay exactly as they are. If you've seen a cellar spider in your home, let me know in the comments below. Thanks so much for watching, and I'll see you on the next one.